All right, continuing on with section 5.4. We're going to keep it simple today. What are medians and altitudes? We're going to figure out what these two things are in triangles. All right, the median of a triangle is a segment that connects a vertex to the midpoint of the opposite side. And the centroid is the point of concurrency of the three medians. So we're going to draw a picture. A median would be when you have the midpoint and you connect the vertex from the opposite vertex to that midpoint. So that blue line is the median. That's what a median would look like. An altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. So if we draw a picture of this, the altitude would be when you draw your line so it's perpendicular to the opposite side. It doesn't necessarily go through the midpoint. It just forms a right angle with the opposite side. So that blue line will be one of them. We can draw a second one. That green line is also an altitude because it goes from the vertex to the opposite side, forming a right angle. And the orthocenter is the point at which the lines containing the three altitudes of a triangle intersect. Okay, so medians and altitudes. Concurrency. The medians of a triangle intersect at a point that is 2/3 of the distance from the vertex to the midpoint of the opposite side. So you can see that red line, AE, is a median. So the distance from A to P, the blue part, is 2/3 of AE. So it's 2/3 of the entire distance. Okay. Likewise, BP is 2/3 of BF. And CP is 2/3 of CD. So 2/3. Medians are 2/3. They intersect at a point that is 2/3 of the way across. So in example 1, what we know is that GM is 2/3 of GL. Okay, and if GM is 2/3 of GL, that means, because this is the bigger part, this is the 2/3 part, this red part, which is ML, 2/3 is part of it, excuse me, 1/3 is the other part. So if GM is 2/3, ML is 1/3. So ML is 1/3 of GL. So those are the things we know. The way I like to think about it is this. If the blue part is bigger, and that's the 2/3 part, and the red part is smaller, that's the 1/3 part. 2/3 is twice as big as 1/3. Okay, so if the bigger part is 6, the smaller part is going to be the bigger part divided by 2. So ML is going to equal 3, because if 2/3 is 6, then 1/3 must be 3. It's half as big. So ML equals 3. And then how big is it from G all the way over to L? GL is 6 plus 3, which is 9. So we were able to find ML and GL. Okay, it says in example 1, suppose FM is 10. So I'll do this in yellow. F to M is 10. We want to find out how big is it from M to K. So we are trying to find M to K. So if you look at the picture, that yellow part is the bigger part. It's the 2/3 part. MK is the smaller part. It's the 1/3 part. So if the bigger part is 10, that must mean MK equals 5. because it's half as big as 10. If 1/3 is 5, 2/3 is 10. And then how big is it from F to K? F to K is 10 plus 5. So FK is 15. So MK is 5 and FK is 15. Again, by using that 2/3, 1/3 relationship. So medians cross at the centroid, and the centroid is 2/3 of the way across the triangle. Okay, we are actually going to skip example 2 with the graphing part. We're not going to worry about that right now. We're going to slide into the theorem. 5.9, concurrency of altitudes. The lines containing the altitudes of a triangle are concurrent. And what that means is that the lines containing them all cross at a point. So you can see that these 3 red altitudes all cross at point G. That's what this theorem says. The altitudes will all cross in one spot. So if we draw them, I'm going to draw the 3 altitudes in 3 different colors. So the altitude from this point up here, this red point, is going to form a right angle with the opposite side. So what you can see is that there already is a right angle formed. This red line right here is one of your altitudes. That blue point, the altitude would go from the blue point to the opposite side and form a right angle. You can see there already is a right angle right in this corner. So that red and the blue line are both altitudes. Lastly, we have to draw an altitude from the green point. And that's just going to be forming a right angle with the opposite side. So all 3 altitudes cross at this point, which we are going to call P. The red, the green, and the blue all cross at point P. Okay, in part B, it's a little different because the triangle is a little different. If I want to draw an altitude from this bottom left corner, this point here, if I try to draw that altitude up here, I can draw these lines, but you'll notice that these lines are not going to form a right angle. Do you see that the angles formed up here do not look like right angles? Okay, so we got to keep looking to draw that line until we get a right angle. So since it doesn't work there, what we actually do is we extend the side. So we're drawing it to this side. We extend this side a little bit. I usually draw a dashed line until we're able to draw a line that is perpendicular. So sometimes we have to extend the opposite side to draw the altitude. So by extending the side, now we can draw the altitude that is perpendicular to the opposite side. If I want to draw the altitude from the red dot, this one works where I can just go straight across. And there's the altitude. And I'm going to extend this red line out so it crosses the blue line. And then if I want to draw an altitude from that green point, again, if I try to draw an altitude in here, inside the triangle, it's not going to work. It doesn't form a right angle. So what we have to do, let me erase this. So what we end up doing is we have to extend this line and then draw a line that's perpendicular. So sometimes you have to extend the lines to draw an altitude, and in the end, the altitude should all cross at one point, and we're going to call that point P. So the blue, the green, and the red are all altitudes. The 2 pictures here look a little different, but you see that all the altitudes cross in one spot. Okay, we're going to skip checkpoint 2 because that goes back to that graphing one. I'm going to go down to checkpoint 3. Find the orthocenter of P. The orthocenter of P in the triangle, and the orthocenter is where the altitudes cross. Okay? So if I draw from the bottom left corner, it looks like it's going to be right about here. Okay. If I draw an altitude from the top, it looks like it's going to be right about there. And then the altitude from that bottom right corner will be right about there. So this time, the 3 points, 3 altitudes all cross inside the triangle. So we have 3 examples there. The last one we just did, point P is inside our triangle. The first example we did, part A, P was on the triangle. And then part B, that P was on the outside of the triangle. So the point of concurrency, which is called the orthocenter, can be inside the triangle, outside the triangle, or on the triangle. All right, and we will run through this proof quickly. It says to prove that BD is a median. Okay. So in proofs, you always start with the given first. So ABC is isosceles. And we'll say with base AC. And we also know that segment BD is altitude. And that is given.
I didn't get that. Could you try again?
All right, so we're trying to prove that that BD is a median. So given that it's an isosceles triangle, you can see up here in the top that those 2 blue segments are congruent. So we would say, all right, well, AB is equal to BC, and that is by definition of isosceles. Step 3, do you notice they share a side? The 2 triangles on the left and the right, that red side. So we're going to say that BD equals BD, and that is a reflexive property. So right now we have 2 sides. And step 4, we're going to say that, actually I'm going to label this 2 to make it less writing. We're going to say angle 1 and angle 2 are right angles. And that is by definition of altitude. Okay, the definition of an altitude is that it forms a perpendicular line with the opposite side. Altitude forms a right angle. And I'm actually going to add a little bit here. So those are right angles. So I'm going to say and triangle ABD and triangle CBD are right triangles. So since they're right angles, therefore those 2 triangles are right triangles. Step 5. We have 2 triangles here. We have a red triangle on the right and a blue triangle on the left. Those 2 triangles are congruent because in a right triangle, there's a hypotenuse and a leg. So we would say triangle ABD congruent to triangle CBD, HL theorem, hypotenuse leg theorem. And we're trying to show that BD is a median. So then we would have to say that, all right, well, AD is equal to CD, and the reason is CPCTC. Corresponding parts of congruent triangles are congruent. So I'm just going to put in one sentence. AD equals CD, therefore BD is a median. Because I'm kind of running out of room there, so I make one long statement. AD equals CD, therefore BD is a median. And that will be CPCTC. So we found out these two things are equal. Okay, for the sake of time, I'm not going to run through the entire proof, but to prove that BD is an angle bisector, you would do the same proof, except for at the end, you would say that these two angles in yellow are congruent by CPCTC. Okay, so it will be the same exact proof, except for in step 6, you would say angle ABD and angle CBD are congruent, therefore BD is an angle bisector. And that will be, again, because of CPCTC. All right, and we are going to stop right there.